is Josh Schroeder. This is my first talk ever at a conference, so take it easy on me. But I'm going to do my best here. A little bit nervous, but I'm actually more excited to just be talking today. So thank you, Sensio, for the opportunity. And today I'm going to be talking about my journey over the last few years into decoupled apps with Symfony. So let's go ahead and just get started. All right, so who is Josh? What is a Kaski? And why do decoupled apps matter? Those are just a few of the things that we're going to get started here. I decided to start with the tough questions first, so take it easy on me. So I'm Josh. I've been doing development for about 12 years now. Worked in a lot of frameworks and languages for that 12 years, but I've been pretty much exclusively working with Symfony for the last 5 years. My first install was Symfony 2.1, so if that is a better perspective as opposed to years. And by the way, I'm pretty excited for 4.0, so that's awesome. So, contrary to popular belief, Kaski is not an abbreviation or term. It's actually a more obscure reference. It's actually ancient Greek for the ribbit sound a frog makes. And the tie-in here is that our founder, Mike LaVista, he went to school in a suburb of Illinois, and their school mascot was a frog, and his name was Kaski. So that's how we got that name. It's actually pretty great, and I'll be quizzing you guys later. So on a more serious note, Kaski is a web development agency. We build custom sites and applications. We pretty much build anything, actually, but usually it's custom sites and applications. We build them for a number of different industries and sectors. As of late, the last couple of years, we've been specializing in nonprofits, universities, and healthcare. We also have really exciting projects in the financial sector, in manufacturing, and our favorite, of course, is the small startup with big ideas. So those are always the most fun. We're a full-service agency, so everything from ideation to content strategy, design to development and support, it's what we do. And quick humble brag, we're pretty good at it. We receive rewards and recognitions every year. Most recently, we were recognized by Clutch Co. as a top development agency and top custom software development agency. So we appreciate the recognition, but that's not the only reason we do it. Our mission is to improve the digital world with products that our clients and their users love long after launch day. And this does tie into my talk, I promise. We've been, for some of our products, to be the best they could, we had to actually think about doing something different than what we've been doing. So we needed to start building decoupled apps. So now we're actually to the reason you guys are here. Now let's talk about decoupled apps. So what is a decoupled application? Some of you may know, some of you may not, so I'll just go over it. There's a few ways to answer that question, but I'll answer it in the context of my talk. A decoupled app in this talk is an application which has its front end decoupled from its back end, where the front end interfaces with a backend API. So an example is a single page app, and it's working with a Symfony REST API in the back. So why does that matter? Why do decoupled apps matter? Single page applications, which are kind of unlocked when you do a decoupled app, they bring significant benefits to unlock capabilities on the web that can't really be rivaled by multi-page applications as far as user experience goes. Many people are moving towards that path, decoupled architectures, not specifically web apps, but in general even. And I think it's for a really good reason. And so part of this talk, it will be to go through kind of what we found why we moved to that single-page apps and the struggles along the way. Let's see. So there's a lot of advantages to decoupling the front end from the back end. I'm not going to cover them all today, but these were the top ones that I picked out. The first one is the ability to build the front end as an SPA, a single page app. Having them decoupled unlocks the full potential of that single page app, let the front end handle all of the routing and all of those things. It's better for performance and scalability. You can develop faster, improve deployments and infrastructure, and additional abstraction layer. So I'm not just going to say those things and move on. I'll dive a little bit deep into each one of these. So single-page applications. First of all, a key advantage of decoupled apps is the ability to build them as single-page apps. That basically it prevents you from having the user reload the page every time they want to go to a new page. That's to put it simply. The beauty of that is that you can control, in a single page app, you can control what happens from the time they click to go to a new page and the time the new page loads. So you can show a loading screen, you can do anything on there. And so overall, the user experience there is going to be much better. And directly with that comes better performance and scalability. There's also advanced front-end tooling. So development-wise, you have a lot of good front-end tools, build tools that you can use with single-page apps that you wouldn't otherwise. Performance-wise, it's going to be a smaller request load on page load, less server-side load because you're not requesting all of the assets on every page load. And then you open up opportunities to code splitting, which is, for those that don't know, it's the ability to load only the parts of the code base that you are actually going to use on that page. So if you have an About Me page, you don't need any of that stuff if you're on the home page, that sort of thing. Let's see. So better performance and scalability. So with a single page app or decoupled app, your front end is going to be all static, ideally. And so you can deploy that and it can be scalable right out of the box. You can take advantage of HTTP caching. And then the backend scaling is theoretically easier. It's not out of the box per se, but if you're doing a REST API on the backend, it's going to be a lot easier to scale that because you don't have to worry about all the code that interacts with that on a multi-page app. Also, having stateless user authentication, there's no need to share PHP sessions across server nodes, and so that removes that blocker there as far as scaling out to multiple nodes. And since the backend data is all accessed through the REST API, then you can take advantage of things like HTTP caching for those endpoints that really only ever get their data updated once a month or something like that. And so it opens up a lot of opportunity here for scaling and performance. Not only does the app get faster, but the development can also get faster. So, some of this may be kind of a paradise world where your developers are perfect unison type, but theoretically it could happen, and it's definitely happened at Kaski. And when you get to a really good steady pace with a front end and back end developer working in parallel, it can be really exciting. You can really knock out a lot of things. So the first point here is that they can work independently with a well-defined API interface. That's the catch there. Theoretically, the backend API could be built first. You have that all defined, and then a front end could be built around that. You could do it vice versa, but I think you definitely want to have that API defined first. They can also work independently without that being fully defined, but have the front end kind of mock data. That's an opportunity there. Another thing that helps with development is your front end devs, if they're not full stack, they're going to be working in a totally separate code base that's all code that they're familiar with. So they don't have to deal with when the backend is throwing errors, things like that. Same thing for backend devs working in familiar code and environment. Allows for rapid prototyping without writing code that will ultimately be scrapped. That's kind of the mock data stuff on the front end there. Let's see. So in addition to development being smoother, decoupling can also lead to deployments and managing the infrastructure, making those things a lot smoother too. So with a separate backend and front end, you're going to have two different deploy pipelines, which can be a pain. It means that you have to manage two separate deployments, but I think it opens up a lot of opportunities there. You don't need to deploy both front-end code and back-end code at the same time, since they are decoupled. You can have totally separate deployment processes that aren't dependent on one another. So if you have changes just on front-end code, you can push just the front-end up. That's a big one there. And then the front-end deployed as a static application. That certainly makes deployments a lot easier. You still have to go through the build process and make sure the environment variables are built in. But it's certainly a lot easier with a static application there. And then more granular versioning, that's kind of vague. But what I mean by that is more granular versioning. That is too vague almost. Let's see, what did I say that for? Yeah, I think what I meant by that was that essentially similar to the first point. I think that was just kind of the first point duplicated. You don't need to tag a new release on the back end if there's no changes there. And so you'll have two separate versioning happening there. Also for that, yeah, I think it's those 2 points together, essentially. I'm just going to skip that one. So, additional abstraction layer. So this is another good point for decoupled applications here. And I think we've all heard abstraction layers. Having just a completely new layer between the front end and back end code, that's really going to help with keeping those things separated. You know, if you have updates in just the back end, you don't have to worry about the front end being changed as long as tests are passing on against the API itself. And one thing that I really like about that is the ability to have different conventions and standards in your two repositories. Some teams will actually still keep the two code bases in a single repository, but I'm a really big fan of keeping flat directories, and so having them separated, you know, the front end devs can really structure it the way they want without actually having any effect on the backend directory structure. Same thing for the backend, and then as far as, I mean, even if you have file naming conventions differently, it's just makes that conversation a lot easier. And similarly, release the front end from the structures and opinions of the backend code as well, which is kind of along those lines. So, to the journey. Our journey can be, and by our, I mean, there's only one of me up here, but that's our company, Kaski. Our journey can be kind of defined by three key iterations. And so the first was just the decision to build single-page applications, which require a Symfony REST API or Symfony backend. The second iteration was kind of just beefing that REST API up with HATEOAS. And then the last iteration was jumping into API platform once we came across that. So we'll jump right into the first iteration that we went through. So we're talking about building a REST API in Symfony, and we've done that before. And this was 3 or 4 years ago that I'm talking about this first iteration. We had done that before with FOS REST and JMS Serializer, but it was we were just serving up Angular through Twig, so it wasn't an actual single page application. I bet you some people have done that here. So we had a big project where we were doing that a lot because we wanted to take advantage of Angular, but we couldn't rewrite the whole thing. And we were kind of sick of jQuery there. So we started adding REST endpoints to our application and started working through that. But we went back to the drawing board when we decided that we were going to build just a fully REST API backend. So we came up with these 3 basic requirements that we had. And this was a REST API that didn't need to be public. So we weren't worried too much about that. This was just for this single app that we were building. So the first one, support JSON. Could support other formats, and it could out of the box with FOS REST, but that was the basic requirement there. The second is user authentication, mainly stateless user authentication. And then third, CORS. I don't know how people pronounce that, but cross-origin resource sharing headers. So make sure that API is sending those headers. And then basic CRUD for REST resources. And lastly, API documentation, which maybe wouldn't be a basic requirement if back then Nelmio API docs didn't exist. But since it did and we knew about it, we just threw that on there. Let's see. So once we had those basic requirements, we jumped into which bundles we were going to use, and we were trying to strip it down. So these are, obviously we used more bundles than this in the application, but these were just the ones directly related here. So our first iteration, we used FOS REST, Lexic JWT authentication bundle, JMS Serializer, Nelmio CORS, and Nelmio API doc bundle. I think most people will be familiar with those. So we just went ahead with this stack, and I think we ended up doing pretty well, all things considered. It was a smaller application that we had to build. We didn't have to get too crazy with anything. Learning JWT authentication was a little bit scary at first because it seemed too easy, but it ultimately was just that straightforward. And in the end, I think we did pretty well, but we did come up with a few limitations with our implementation that we wanted to iterate on. So essentially the outcome was, we were able to meet each of the base requirements for that API, but we did identify some limitations and while working through it. And so the first one, felt really bad hard coding those paths to the REST resources in the front end code. It was miserable, didn't like it. The second was embedded relationships in REST data are not self-describing. I'm not sure that's the phrase to use, the proper phrase to use, but essentially you have a nested object in the JSON, and you don't really know what that object is aside from the key that's identifying it. And so, lastly, not able to easily accommodate different contexts of the same REST resource. So I couldn't come up with a better way to say that, but essentially, in your application, you're going to be requesting the same resource, REST resource, but expecting different data or needing to use different data. Maybe it's based on the user role. maybe it's just based on where it's being used in the application. And so one thing we struggled with a little bit, we did get groups set up with the serializers, but as far as coming up with a good way to actually send which group you're expecting, especially if it's based on the user role, we ended up doing it, but it was a little messy there. So you're right in the line of whether you spend a lot of time to write a lot of custom code around that, or just deal with sending extra data in places where you don't need it. And so these were 3 that we thought we could solve pretty easily. So in our next iteration, we grabbed 2 of them that we wanted to solve. So we set out to solve the hard-coded paths issue, and then also the embedded relationships in REST data not self-describing. And the reason that that could be a bad thing, I just kind of glazed over that, is it still couples the front end to the back end in a way. And the goal here is to decouple that entirely. Obviously, you're going to be expecting certain data structures, so you can't really get around that part of the coupling. But this was one thing that we saw we could decouple further. That way, the paths to those REST resources could change without having to write or update the front end. And then the second one we wanted to tackle was the embedded relationships in REST data are not self-describing. So that's a little bit, those 2 are essentially solved by the same thing. But the reason we wanted to tackle that was very similar to that, but also just being more certain about the data that we're passing back and forth, and the expectations as far as, if we're sending nested relationships on the front end to the back end, we want to make sure that those are the correct types, vice versa. So we decided to add another requirement to our REST API, which is that the API is discoverable by the consumer without having prior knowledge of the API's interface. And so we came across this HATEOAS, and that's another one I don't know how to pronounce, but I'm going to go with that pronunciation. It stands for Hypermedia as the engine of application state. So essentially implements a REST API that implements this constraint will include Hypermedia links to related resources to that resource that you're requesting. It could also return embedded resources with that response data. And so the bundle we ended up using for this was the Bazinga HATEOAS bundle by Wilderant. So I have an example here. The user representation without HATEOAS on the left. It's just a simple user object, 3 keys there. And then on the right is the representation with HATEOAS. And so the difference here, you'll see there is an underscore links and underscore embedded keys in this object. Those are standardized by HATEOAS as the key names. And then essentially in links, that will be linking to related resources or itself. And so in this case, there's self, and then there's manager. And so in the links, those could be, they don't have to be a specific relationship. It could also be an action to take. And then down here is an example of the manager actually being embedded as well. Oh, it doesn't show up on that screen? Let's see. There we go. Yeah, so this is the example of the manager being embedded here. And then you can see that the links for that manager are here as well. And so then this href here is the actual API resource. And so the goal here is to solve that issue where we need to hard code those URLs on the front end. And then also it does kind of explain the relationships a bit deeper there. So you now have a self key here, which you could parse this URL and determine which type it is. It's not ideal. There's other ways to solve that. But that's what we did to solve those problems. And so it does take a lot of determination to make sure that you're actually using those links instead of just hard coding those URLs. So you can't be lazy on that. But we ended up with this project doing a really good job with that, where we were able to just hit the single endpoint, and then that would go through and discover the API. And we still have the keys coupled and the name of the actions in the links and the embedded things. But we were able to get rid of all of those hard-coded URLs, which was pretty great. So for that project, just for the context, it was built in Angularjs, and it relies on those links and embedded resources. So jumping ahead to the third iteration, what we're doing now. So I don't recall exactly when we found it, and I actually don't know when the first stable release was out, but for API platform, when we found that, it seemed like somewhat magical and the unicorn that we were looking for, as far as just really doing almost everything for you. So jumping into that a little bit, unfortunately I didn't think I'd have enough time, but I think I talked too fast. Didn't think I would have enough time to get too deep and technical into API platform, but I do have some examples and can talk about it a little bit. APIplatform.com, if you're unfamiliar with it, its tagline is the ultimate PHP framework to build modern web APIs. It's built on top of the Symfony framework, and the default dist of it is a Symfony full stack application. And I think, I don't recall when 2.0 came out, but I think it was more tightly coupled with Symfony before in version 1. But V2 seems to be doing really awesome things. So high-level overview of API platform. So you can create a CRUD API in minutes. I'm not kidding, but also that's what they say on their site. So maybe they were kidding and I just took it wrong. I don't know. But I've definitely done it, so it's true. It's able to create a full REST API with CRUD functionality just based on your PHP model classes. And so it has it has Doctrine integration already implemented. And so if you have your Doctrine entity set up, it's a matter of just adding a few annotations on each entity. You probably don't want the default settings because it adds methods for get, post, put, delete for everything by default. But it's a CRUD API, so they're true there. So what we really liked about this was that it did a lot of the features already built in out of the box that we seem to end up having to write over and over and over on every project. And it's almost always the boilerplate code. And so it was almost like when we found this, we were like, thank you. Yes, finally, we found it. And so the main features that it has data validation built in, it uses forms underneath, so that's built in there. Pagination, filtering, sorting. It has the Nomio API docs, but it also has Swagger docs, which I think Nomio is using now. And then one thing that it has is uses Hydra, which is a machine-readable documentation. And so with that, in addition to the HATEOAS things that are included with JSON LD, it actually solved that. I guess it wasn't an issue I brought up in the second iteration, but the fact that the types weren't clearly defined there. So with Hydra, the types will be clearly defined in all of the responses. It will have a ID key, and then also the type and a link to the schema for that entity. So that's really good. It has their documentation. I struggled with it a little bit in V1, but V2 they really ramped it up, and I haven't had too many issues there. So they have a lot of user guides written for, if you want to set up lexic JWT, they have that set up and it works. Setting up CORS headers, I mean, that's straightforward. And then they also do HTTP caching. I think that's built in, but it may just be, they have documentation for that. So back to our REST API requirements. This one kind of blows it out of the water without having to really do anything. All we have to do is set up our entities with the API resource annotation, and it blows our requirements out of the water there. So it covers all of these bases, and then all of these additional features here. Let's see. Yeah, I think I covered most of those. So I'll just do a very short intro to it if you guys haven't seen it. All right, cool. So that's up there. So the only thing that really matters on this page is that API resource annotation on the class. By default, it's going to add a REST endpoint for get, post, put, delete, and it will essentially use kind of best guesses as far as field types goes. So with Doctrine, luckily, it will use the Doctrine field types that you have set up first. I've worked with custom data providers with it, where those Doctrine, we weren't using Doctrine for that, and it defaults back down to the @var doc block if you have that set. One thing we found an issue with that is if you have a nullable field and you have string pipe null, it's actually going to fail usually because it can't read that correctly. Maybe updated now, but that was one thing where I was kind of iffy about. Ended up having to remove some of those doc blocks because of that, just get around that issue. But overall, it's able to read Doctrine entities really, really well. And so it really is just adding that annotation there. You're probably going to want to configure it further so that you don't expose your API to bad things. Here's another class. So the previous one, I'll just jump back to that. Oops. So this was offer. I don't think it has any. Yeah, so it has an association to the product entity. Oh, and then that product entity was the first one. And so by default, those things will be set up. You don't have to set up any Symfony forms or anything like that. It's going to manage embedded things automatically. It's all based on, well, it's not automatically, it's all based on Serializer. And so if you have groups set up with Serializer to extend into nested relationships, then those things will be exposed in the API. And so you can use Serializer Groups to determine which things can be written versus read. Here's an example of configuring the operations. And so most of the configuration will end up in these annotations. And so this is essentially just exposing the get method in both the item and collection operations. And so this is how you would essentially limit all of the other operations. You can do that on a global level as well, but that's just an example there. So that's actually all I had for that small intro into it, but the documentation is pretty good if you guys want to check that out, apiplatform.com. And then you can find a link to the API Platform Standard Edition on there as well. I'd recommend doing that. Last time I checked, it was still on Symfony 2.8, I think, so I'm not sure if they've updated that yet. So maybe you don't want to use that one. But let's see. So what's next for us as far as Kaski? We found our holy grail with API Platform, but is it really the holy grail? We have yet to find out, I guess. We've definitely had a lot of challenges with it. and pushed it a little bit further than the documentation could guide us. We set up custom data providers for a WordPress REST API and got it all working through API Platform, which was a little bit more work in the end than just setting up controller actions and hitting that REST API, but then we got all of the additional features built in, filtering, sorting, pagination with that REST API. So that was actually pretty nice. I think one thing we struggled with initially with API Platform was the fact that you kind of work with it a little bit differently than you're used to with Symfony. There's no controllers. They actually prefer, you can use a controller because it uses routing, but they prefer using a action domain responder instead of MVC. And so then they have actions instead of controllers. Essentially an action just handles a single operation for that resource. Working with it, it was really straightforward once you got down to it. So that was pretty good. And then it's a lot of just event listeners as opposed to writing controller code. So, jumping into that after FOS REST, it was just kind of like, this is not what I was doing a week ago, and it's the same framework. But once you dive deep into that, it's actually really powerful. All of the event dispatchers, the events that are dispatched, it's pretty granular. So we haven't pushed it to its limits yet. And there's also additional features being built around it. There's a React admin panel that's being built that essentially uses the API Platform API. So it's a fully discoverable API, and so the React admin just works directly with that. It's similar to Sonata admin, except for you don't need to actually configure anything since it reads the API there. And there's, I forgot there was another feature that I just saw that they were working on there. I think it was before they only had Angularjs kind of generators for working directly with their API and reading those. And I just saw that they have React generators for that now too. So it's pretty cool. As far as what's next for us, we don't really know. We're happy. We're in a good spot with that right now. But I think the only thing we've been intrigued by is GraphQL. We're starting a project with that in a couple of weeks. So we'll be picking that up pretty quickly. And we'll definitely be at the talk tomorrow, improving API communication using GraphQL. Really excited for that one. And I think that's pretty much it for GraphQL because I don't actually know much about it yet. So closing notes, we have a booth shared with ICC, International Code Council. So if you guys want to come by and see some decoupled apps that we've built, we also have a PHP library that it's getting a lot of traffic on Packagist, and that's the first one that we really had kind of blow up like that. So we just figured we would show that one too. It does have a Symfony bundle, but the actual library itself is mostly plain PHP. And then one of our other developers, Dave, is doing a talk building an admin backend with Sonata admin. That's kind of we always tie in FOS REST and Sonata admin. Ends up being a really cool thing. So that's tomorrow at 2:45 if you guys want to come for that. And I believe that's everything. So thank you all very much. Appreciate it. Thanks for bearing with me.